Good morning, my dear subscribers. This is video number 402, and in this video I am going to explain analysis of covariance, that is ANCOVA. I'll also discuss the computation and interpretation of the results of analysis of covariance using SPSS. ANCOVA is the extension of analysis of variance, that is ANOVA, in which we would like to determine if there is a statistically significant difference between three or more independent groups after accounting for one or more covariates. Now, what is a covariate? A covariate is a continuous variable that covaries with the response variables. For example, we take an example and we want to know whether or not studying technique has an impact on exam scores, but we want to account for the grade that the student already has in the class. We can use their current grade as a covariate and conduct an ANCOVA to determine if there is a statistically significant difference between the average of exam scores of the three groups, that is three different groups. So my response variable will be exam score, and the fixed factors are studying techniques. There may be more than two studying techniques, and the current grade of the students would be covariate. This will allow us to test whether studying technique has an impact on exam scores or not after the influence of the covariate has been removed. Thus, if we find that there is a statistically significant difference in exam scores between the three studying techniques, we can be sure that this difference exists even after controlling for the student's current grade in the class. There are a number of assumptions of ANCOVA, and before we perform ANCOVA, it is important to make sure the following assumptions are met. The covariates and the factor variables should be independent of each other. The covariates are continuous data. They should be continuous and be measured either on interval scale or on a ratio scale. Assumption number 3 is homogeneity of variance, that is, the variances among the groups should be homogeneous. The observations in each group should be independent. The data should be roughly normally distributed in each group, and there should be no extreme outliers in any of the groups that could significantly affect the results of ANCOVA. Now, we try to answer how to perform ANCOVA in SPSS. This lecture shows how to carry out an ANCOVA using SPSS statistics as well as interpret and report the results from this test. Now, we will give an example, and this is a hypothetical data that I have downloaded from the net. There are three variables. The studying technique, this is the categorical variable. There are three categories. One stands for technique A, two stands for technique B, and 3 stands for technique C. Second variable is current grade of the student, and this is the final exam score. So again, my response variable is exam score. Studying technique is an independent categorical variable, and covariate is current grade of the students. Let me open my data file in SPSS, and I'll show how to carry out the one-way ANCOVA in SPSS. So let me go to my data. This is my data file in SPSS, and I'll explain how to do that. So in general linear models, I'll press univariate, and then I'll send a exam score, which is my response variable, to dependent variable list, and the studying technique, which is independent categorical variable, I will put it here, and current grade is my covariate. That is the continuous variable which covary with the dependent variable. After this, I'll click on model, and this should be checked, full factorial. After this, I'll click on options, and in options, I'll send it here. I will check this because I am comparing the main effects, and for this I should check this Bonferroni. I'll also check descriptive statistics and homogeneity test and estimate of the effect size. So after that I'll continue, and these are my results. Now this shows the mean exam score for those who used technique A. This is the mean exam score for those who used technique B, and this is the mean exam score for those who used technique C, and finally this is the mean exam score for the overall students. These are their standard deviations, and here is the Levene's test of equality of the error variance, and the null hypothesis is that the variance of the three different groups is homogeneous. That is, the variance does not change across groups. Since this F state is 0.664 and its p value is 0.53, which is greater than 0.05, so we fail to reject the null hypothesis, and we accept that the variance of the three groups are homogeneous. Here is the test between subject effects, and since we are comparing the mean exam score for the three different studying techniques, so we would look at this F statistics. So this F statistic is 4.8 and its p value is 0.32, which is less than 0.05. So we reject the null hypothesis that the mean score of the three different groups is the same. So it means that the exam scores for the three different techniques is significantly different. The mean for the three different groups is not the same. Now, in order to know which two groups have significantly different score, we will do that in the below analysis. This is the estimated marginal means. Before it was 75, now it is before it was 76 point something, now it is 75.94, and this is 88.4, and this technique C is also 83.590, and these are their standard errors. And here is the post hoc test for the comparison of the means of exam score for the various groups. Since there are three groups, technique A, technique B, and technique C. So if you compare technique A and technique B, then the p value is 0.031, which is less than 0.05. So it means that the mean exam score for technique A and technique B is statistically significant. They are not the same. However, if we compare the mean score of technique A and technique C, then based on this p value, we fail to reject the null hypothesis that the mean score of used by students using technique A and technique C is the same. Similarly, technique B and technique A is the same like technique A and B. So this p value is the same. So it means that the mean score of the students using technique A and technique B is not the same. While comparing technique C and technique B, the p value is greater than 0.05. So it means that only the mean exam score of technique A and technique B is significantly different, while it is statistically not significant if we compare the mean exam score for technique A and technique C, and similarly technique B and technique C. So this is the post hoc analysis, and finally This is the univariate test. The dependent variable is exam score. The F test, test the effect of studying technique. The test is based on the linear independent. Okay, now let me explain this in my presentation. So I have given some explanation to this. As I showed you in the analysis, we see that there is a significant difference in exam score as F is 4.810, which is this. P value is 0.032, not this, between the study technique while adjusting for the current grade. The partial eta squared value, that is 0.467, indicates the effect size and should be compared with the Cohen's guidelines. And it can be seen that for the study technique, the effect size is almost moderate. If this is about 0.5, then it's moderate. So this value is also used to describe how much of the variance in the dependent variable is explained by the independent variable. So it means almost 47% of the variation in the exam score is explained by study techniques. Ideally, this number would be close to 1. These are the other tables that I already explained, and the p-value for the study technique is 0.032. Since this value is less than 0.05, we can reject the null hypothesis that each of the studying techniques lead to the same average exam score, even after accounting for the student's current grade in the class. So the conclusion is that even if we control for the student's current grade, the various techniques does not produce the same average exam score. And as I showed it in one of the table, if you look at this, the difference between technique A and technique B is statistically significant, and there is a huge difference between the mean score of technique B and the mean score of the technique A. So my dear students, my dear subscribers, this is how we use ANCOVA and how we compute it in SPSS, and what is the interpretation of this analysis of covariance. So this is a little bit a difference from simple ANOVA because this is the extension of the ANOVA. Kindly subscribe to the channel and do not forget to click on the bell icon.